Okay, so why would we even want to launch a rocket from a balloon? Well, first, the simple thing is you get a free 100,000 feet or so. I mean, balloons can go at least 120, 130,000 feet, but 100,000 feet is a pretty good starting point. You know, to get anywhere close to that with launching a rocket from the ground, you need just huge rockets, like very expensive, solid, you know, a lot of power. And then the air resistance is super high down here, so the rocket has to be very strong. Up at 100,000 feet, the air resistance is about 1%. At 164,000 feet, it's about 0.1%. So you get rid of one of the dominant forces that prevent the rocket from going higher by launching from pretty high up. The gravity is a little bit lower, not much. And ultimately, it's just a cool physics challenge, as you'll see. And, you know, you're probably just watching Netflix anyway, so it's something to do. So the origin of the idea is, you know, everybody comes up with this idea on their own and they think they came up with it. I came up with it independently, you came up with it independently, it doesn't matter. It goes all the way back to the 1950s, I think it was proposed, and they were gonna shoot, I think it was the Army, US Army, shooting a rocket and they would go right through the balloon, which is kind of an interesting idea. I don't know if they did it, they might have. I know there's a few companies that are looking at it, like at least one startup and me. Okay, so it seems simple enough to launch a rocket, right? You just strap it to a balloon and ignite it and there it goes and it's done. But it's actually a lot more complicated than that. So the first challenge is rocket stability. So when you're launching a rocket down from Earth, where you have a lot of air resistance, if it's traveling up, straight up, then a small wind gust or deviation in the propulsion that kinks it out one way or the other, the air resistance going down will put more force on the back end than the front, and it'll cause it to automatically right. So it's basically a weather vane. That doesn't really work at 100,000 feet with much less air. So you made very big fins, but you can't count on that. So there's other methods, like could you spin the rocket? You know, you throw a spiral football and the stability comes from, you know, the spin. I looked into that, I did some experiments, but the fixture required to stably spin a rocket at such a speed is actually pretty heavy, and I don't want to have that mass hanging from the balloon because we're really constrained by how much we can actually lift, so we don't want extra equipment. You could do an active control system, thrust vector control, like our friends at bps.space do a really cool, you know, thrust vector mount where they're adaptively controlling. But the thing that works for me is an internal spin mass that I've been developing, and it's just basically so simple. You put in inside the rocket a mass, and it spins, and that's where the stability is going to come from. And when I do some experiments, future videos, we'll start to see why there's some advantages to doing it that way. So stability is a big problem. So then you have to launch in a fixed direction. So if you're launching from Earth, there's like a big support ground that holds the rocket in place and only allows it to go straight up. And so the rocket can get a bunch of momentum, so then it has stability as soon as it leaves the launch rod. So we don't have a launch rod, so we're gonna have to, you know, make sure we're launching in a fixed direction in intelligent ways as well. And then finally, if the balloon is still up there, how do we get around the balloon? So that's one I haven't quite figured out yet, but you know, as I mentioned, the Army, they were like, we're gonna shoot right through the balloon. So this is why it's a cool problem, and in future videos show like some of the experiments and stuff that I've done and take it from there.